Hi, my name is Blake Wolf. I worked on a team with Adrian Guyton. We both work on machine learning research at the Toyota Research Institute, and this presentation covers our motivation for participating and our approach. So I personally was interested in the competition for entertainment and educational reasons, and both of us, I think that generalization in RL is an interesting and important problem. Here's a summary of our approach. We use Phasic policy gradient with data augmentation, some RL tricks, and hyperparameter tuning. If you're not familiar with phasic policy gradient, it's basically an extension of PPO where you use separate policy and value networks. The first phase operates very similarly to PPO, except you store state and value target tuples in a buffer as you go. And then in the secondary phase or auxiliary phase, you optimize a joint loss with respect to the policy parameters, which is just a behavioral cloning loss and a value target loss. And then you also optimize the value network. The paper also describes a version where you use a single network, which is what we did for computational reasons. In this case, they detached the value head during the policy optimization. But we found that this led to some instability in some environments, so we left it attached and instead just reduced this loss coefficient. Second, we used some data augmentation. So we only applied it during the auxiliary phase, not the policy optimization phase. So by that I mean we just only used it here. You can see this first reference for why we chose to do that. Second, which augmentations did we use? We ended up using just random translate. We implemented most of the augmentations from this second reference, but found that while some of them helped in certain environments, they often hurt in others. And figuring out which to use online proved to be pretty difficult. Third, we used some RL tricks. So we tried most of the methods from this first reference, but ended up just using reward normalization. And second, we did some reward shaping. Basically, we penalized no-op actions. And we did that by just looking at when the observation did not change. Fourth, we did some hyperparameter tuning. So here I'm just showing the hyperparameters that are different from their default values that I think are important. Lastly, I think it's interesting to see what people tried and couldn't get to work better. And that's what I'm showing here for us. I'm particularly interested to see whether anyone got DQN or SAC to work well. Okay, thanks to AI Crowd and OpenAI for organizing the competition. I really enjoyed participating, and I hope y'all do it again in the future. Thanks.